Solving quadratic equations. So today we are going to start the eventual journey of solving all of the various types of quadratics that you're going to need. Today we're going to solve with square roots. Tomorrow and next week, the quadratics part 3 is going to go over factoring, which is going to require that thinking with the area puzzles that we've been doing. So this is not going to connect to those area puzzles, but this is step 1 in solving quadratics. Now all of these are quadratic equations because the variable is squared, x squared, a squared, a squared. That automatically means we're dealing with a quadratic equation. So the question here is when we just have a problem like this, x squared equals 9, we had to figure out how do we get rid of the exponent of 2. What is the inverse operation? And from now on, guys, our new inverse operation for exponents are square roots. So if you see that exponent of x squared, I take the square root, which is like a check with a box on both sides, and inverse operations undo each other. So the square root and the 2 go away. And now we just have to think about what is the answer to the square root of 9. Now the square root asks you, what number times itself will get you back to 9? Oh, well, 3. 3 times 3 is 9. But there's also another answer. Whenever we deal with square roots, logically, we know positive 3 times positive 3 is 9, but negative 3 times negative 3 is also a positive 9. So we have 2 answers this time when you use your new inverse operation. When we see x squared, we're going to use square root as our inverse. But before we can use that very helpful tool of square roots, you have to completely isolate your variable with that exponent. So a squared still has a 10 on this side. So before we can use our square roots like over here, we have to get rid of that plus 10. Since we're moving it to the other side, the opposite is subtracting 10. Now that a squared is totally alone, I can take my square root, my check with a box on top, and I'm just left with a equals, what number times itself will give me 25? 5 times 5 is 25. Negative 5 times negative 5 is also a positive 25. Once again, we got 2 answers. Now over here, it's going to get slightly more complicated. We still need to completely isolate the a squared before we use our new inverse operations from the first 2 examples, before we get to that square root part, okay? So over here, I see I have the 64 and the negative 1. I'm going to get rid of that negative 1 by adding. Now I need to get rid of that 64 before I deal with the exponent. That's 64 times a squared. So I'm going to divide both sides. And then a squared. 36 by 64, we get this crazy decimal in the calculator. We can still keep solving. To get rid of a squared, now that it's totally alone, the square root. So that'll give us a equals. Now, the way to do this now is to go find the square root button on your calculator by hitting second, the blue button on top, and x squared. And in your calculator, you should see the square root button pop up. And when we make that happen, when you do the square root of 0.5625, we get 0.75, and we have to know we also get negative 0.75, even though your calculator won't write that. We always will get that positive and negative answer when we solve with square roots.